Are magnetic fields and magnetic flux the same for Faraday's law? Imagine holding a magnet near a coil of wire and watching the electricity flow. That's the magic of electromagnetic induction, and it all comes down to understanding magnetic fields and magnetic flux. But are they the same thing? Let's find out. A magnetic field is like an invisible force field around a magnet. It has both strength and direction, which we call a vector. Think of it as the area where magnetic influence exists. The magnetic flux density, often called B, describes this field at each point in space. Its units are Teslas, and it tells us how strong the magnetic influence is at any location. Magnetic flux, however, is a different idea. It measures how much magnetic field passes through a specific area. Imagine a flat surface like a loop of wire. The magnetic flux is the total amount of magnetic field passing through that surface. It depends on how strong the magnetic field is, the size of the area, and the angle between the magnetic field lines and the surface normal. The units for magnetic flux are Webers, which are equivalent to Tesla meters squared. Now, in the context of Faraday's law, magnetic flux is the star. The law states that if the magnetic flux through a loop changes over time, it induces an electric voltage, or electromotive force. This is written as mf equals negative the rate of change of magnetic flux. The negative sign shows that the induced current opposes the change, a principle called Lenz's law. So, are magnetic fields and magnetic flux the same? Not quite. The magnetic field is a local property describing the magnetic influence at each point. Magnetic flux is a measure of how much of that field passes through a particular area. Think of the magnetic field as the environment and magnetic flux as the effect of that environment on a specific surface. In real-world electrical devices like generators and transformers, changing magnetic flux is what creates electricity. The magnetic field is the cause, and the flux is the effect measured over an area. They are related but not identical. The magnetic field influences the flux, but the flux depends on the field and the area it passes through. In summary, magnetic fields and magnetic flux are connected but serve different roles in Faraday's law. The magnetic field tells us about the magnetic environment at each point, while magnetic flux measures how much of that environment passes through a surface. Understanding this difference helps us grasp how changing magnetic conditions generate electrical energy in many electrical engineering applications.